Good morning, everyone. We are about to start. I hope you can see me. Please let me know if the sound is good. Can someone confirm if the sound check, everything? Can you hear me okay? You can say yes on the chat. Thank you. Thank you, everyone. Thank you. All right, let's get started. Good morning. Happy Wednesday, everyone. Thank you. Thank you for making it for joining me today again. This is another episode of our data engineering process fundamentals. Today we are looking into data analysis and visualization. So this is the um, the phase of that process where we actually look at data from a data warehouse standpoint, and we go through the process of understanding how to do analysis and how to visualize the data and compare the different approaches to this, whether it's code based or low code. So thank you for making it today. My name is Oscar Garcia. I'm a principal software engineer, and I do this for fun. I enjoy sharing this information with you. So to get going, to get started, right? I'm sure you've been introduced to projects, or you've been presented with a challenge to start a project where you need to do some kind of data analysis and kind of create reports, right? And often the case is you may not know what kind of report or to produce for the business, right? So hopefully after today, this presentation gives you some insights on how to do that. How do I go about to do that? What is the thinking process and the questions perhaps to ask the product owner or the business owner on what they are looking for, so you can focus and you can deliver that. First of all, some housekeeping tips, please. If you're part of the GDG network, please use the chat for questions. If you're coming in from a different channel like YouTube, please go ahead and use the chat for questions. Please enjoy the presentation. I have shared with you some of the links for some of the resources that use the GitHub repo for the source code and for all the background about what we're doing. You can use the YouTube channel for additional information and background on other episodes and things that we have created. I'm also an author. I've written this book, Data Engineering Process Fundamental, and there is a book on Amazon where you can actually take a look, download a demo chapter, and learn more about this process. And I hope this gives you more in-depth knowledge of what we're talking about today. But going back, so you're presented with that challenge. So how do we gather insights from data, right? So that's the biggest challenge. You're presented with some information. Hey, we need to do data analysis, and I need to see some reports. How do you go about to do that, right? So we have to. There's two principal concepts here. So it's data analysis and visualization, right? So data analysis is really where we actually need to look at the data, whether it's coming from a data warehouse or whether it's coming from some CSV raw data, but you need to look at the data, understand its strengths, right, and be able to understand what the data is telling us. And there's visualization, which what visualization would do now is, instead of just creating a flat report like a grid, a table with all this information, you can create something visual, something that's very attractive to the end user. Because for us humans, right, we use our brain and visualize things, and we tend to understand things much better, especially when you're talking about us executives, right? Principals of the business, right? They don't like to see just numbers. They like to see some charts with colors and things of that nature. So today we are exploring these concepts, right? We're looking at data modeling, which is key for any report to work, right? Data modeling is a key concept here. We're looking at data analysis using tools like Python, Jupyter Notebook, Visual Studio Code. We comparing some of the concepts like a statistical analysis and business intelligence. What is that applicable for? things of that nature. We're also looking, of course, we're diving into data visualization, understand some of the design principles, chart types, why you will do it, what the code-centric approach, and why you would do it, when you can do that, or just use a enterprise tool, low-code tool like Looker, Power BI, Tableau, and other tools that are available for us to create quick visualizations. All right, so we start with data modeling, right? So you may have a data warehouse where they give you the data, they tell you this is what's available, or you may not, you may have some raw data, right? So but the concept here is that the data modeling is a foundation for a data warehouse or any data project, right? We start by getting some raw data from someplace, right, which is part of that project, and you kind of process that data, and you go through a whole process of discovery to understand the data and write requirements for it. But the end goal here is that off of that raw data, you need to come out with some data models, right? Some logical data models to be able to kind of interpret. Instead of just creating one flat table, you need to create, you need to do what's called dimensional modeling, which is identifying the dimensions and identifying the fact tables for this, the facts. So the facts are really the measures, right? What are you presenting? What are you calculating? What are your totals? Those numbers that are the key numbers, digits for any kind of report that goes into the fact table and is surrounded by categorical properties, which are the dimension tables. Like, for example, in this simple design, we have a dimension for station and booth, right? And there's a whole background about this, about what we are trying to do. So we'll cover a little bit of that in the next steps. But for now, understand that this is the approach, right? You need to do data modeling. There is something missing out of this simple data model that's there that is a very key component, right? And if you haven't guessed, then what that is really the date dimension. This is an often overlooked dimension table, but what this really does, it gives you granularity, ability, right, to be able to report by year, quarter, month, and day. But then you will think, hey, but if I have a table and I have the date, wouldn't I be able to do so, to just calculate the years and dates and all that? And the answer is yes. Definitely you can do that. And if the data is small, of course it works. However, once you start addressing big data issues, big data concerns, what will happen is as you build a report, you probably provide some filtering criteria, right? And that filtering criteria has to give you maybe a drop down, some date picker, be able to for you to select what dates to pick, or perhaps what quarter of the year, or what weekends, or specific days like Monday, Tuesdays. Once you deal into that kind of modeling selection, then a dimension or calendar table is important, because the amount of data that's going to be in there is way less than the amount of data that you can find on a fact table, right? So what that enables the report is to perform, is to be able to give you that filtering capability. I don't know if you've seen some reports where you select a particular date, and the report's just locking up because it's probably reading records from the data set and is loading too much data. But if it's just loading from a dimension table, it will be very, very fast. So that's the whole purpose of this, right? And this table is calendar table or dimension date table, is designed for filtering criteria, grouping criteria, any kind of uh, timeline analysis that you need to do for your system. Okay. So after we understand our data modeling, we need to go to data analysis, right? Well, what is data analysis? This is really just that process where you're doing data mining, right? Where you're really exploring the data, you kind of identifying what's in the data, right? And what it really means, right? What are we looking for, and what are we trying to display or to report on, right? It really just involves activities like, for example, identifying those dimensions, right? What is a categorical column here? What's a dimension, right? And categorical is important because it gives you the ability to do the grouping by, right? So you can do aggregations by that category, right? And the measures, as I spoke before, where you need to do the totals, right? So the process is really to kind of understand the data, understand how good the data is, understand, like, identifying outliers. So outliers could be numbers that are completely off due to something, right? Sometimes they're valid, sometimes they are invalid, right? So in certain processes, an outlier may be just some dummy data or something that happened that you want to take out of the system. But in some systems, particular, for example, when a time series, those records may be impacted by maybe holidays, where there is a very low number or maybe a high number. So we just need to go through that process and understand it. But when it comes to the toolings that we need to do, we can actually use coding tools like Python, SQL, Jupyter Notebooks, right, to be able to load data, read the data from CSV or from a data warehouse and process the data. If you need to use some kind of visualization modeling, you can use things like Plotly, which is a tool that enables us to, through code, create our bar charts or pie charts and dashboards, right? And we'll look at that more in detail. Or you can use low-code tools like Looker, right? Looker, Power BI, Tableau, they're enterprise tools that are very friendly, very easy to use, and you have so much tooling to be able to do the data modeling, right? So when it comes to data analysis, we need to start doing some kind of profiling, right? So what is profiling? It's really that process to identify the data types. This is important, right? So we need to have the right data types so we're able to identify the right categorical versus the measures, right? So you identify the data types, you identify the dimensions, you identify the measures. And there is a process to do that, right? Sometimes you look at the data and you say, yes, I know that one is a string, so therefore I do that. That one is a number, so I do that, right? But there are tools to be able to do this in an elegant way and be able to use tooling to be able to do some statistics around it. So you're able to see that, oh, okay, this is a category because it has these names, and it has, most of those names are, like in this case, you will see in this image, you will see like street or avenue. And what that does is that tells you that these are very common words within those categories, right? So this is just giving you an idea that these are some kind of locations. All right, so part of data analysis as well is the process to clean up and pre-process the data, right? So to clean up and process the data, we need to look for nulls. We need to make decisions if the data is null or empty, to be able to set it to 0 or to drop the records, right? So that process to identify, do I drop the records or set it to 0? What is the right thing for me, right? And also to cast the data with the right types, right? So if it is an integer, cast it as an integer. If it is a datetime, cast it as a datetime. And what you can see here in the image is how you can do that through Python, right? And Pandas. And we'll see that more in detail. So, but you need to clean up bad data, and you need to pre-process the field by casting the fields correctly to the data type, renaming the columns, and follow your naming conventions and your standards. You may want all capital letters, you may want small letters, what have you. Is really to actually follow your process and actually define your standards. Process outliers. So part of that is what we just talked about a little bit. How do we go and identify the outliers in our data set, right? You can actually use things, concept called C-score. And this starts leaning towards the statistical analysis, right? Where you actually, there's a formula to be able to get the mean or the average and divide that by the standard deviation. And don't worry if you're not familiar with those concepts, but that's statistical analysis, right? So what that's doing is just really taking up the series of numbers and saying, based on all these numbers, I want to get the average, right? And the standard deviation. And anything that goes beyond, let's say, 3 as a threshold, which is very common, is over that average. And if it's over that average, if you see a graph, you will see that completely off of that average, whether it's negative or positive, and that gives you, that's an outlier. So depending on what you're trying to achieve, that outlier is something that you could throw away or something that you need to look into a little more, right? It may be a positive outlier, so you need to adjust your threshold. A statistical analysis basically focuses on the draw meaningful information using mathematical computations, probability theory, correlation analysis, and this is key. I talk about this data analysis. I'm sorry, statistical analysis, because now this is becoming very common when we talked about data science and machine learning, right? A few years ago, statistical analysis was really big in scientific areas and manufacturing. With now, if you get into machine learning, you'll see a lot of statistical analysis, a lot of formulas that are being used and applied for these AI models, for machine learning models. So it's very important. But what it really aims to do is tries to find a correlation coefficient, right? So this gets deeper into that. So don't worry too much if this is new to you. But it's just really to see how significant the linear relationship is. And this is what machine learning does a lot, right? It just looks for how significant the relationship is to be able to kind of predict an outcome, especially when it's talking about linear regression analysis. And if you read into machine learning, you'll see that's one of the very popular model, right? So they use this concept for that, right? This may not be something applicable to you, but understanding is there. It's just one of those things eventually you may come across and maybe not. But the point here is that if the p-value, the result of this calculation, p-value goes towards to zero, then they're very significant. They're statistically significant, meaning they impact each other. They do have a relationship. If they're way closer to one, positive number or negative, they're not related. They don't impact each other. So it's just a normal concept, right? To have. For those that do more like the business intelligence and reporting, this is another concept, right? That where we actually go through a BI process where we actually collect data, analyze it, and present it in some forms of reports, and be able to tell the business, hey, these are your KPIs, these are the things that are important, right? So, for example, what are the sales of the week? What are the sales of the month? And so on, right? So BI is very important for that, right? So what it does, it really looks especially at distribution, which what that means is really what, for example, what region had the most sales, and or what department had the most sales and things like that. It focuses on analysis by locations, by day, by time period, and it provides insights that impact the business operation. So this is really what the CEOs, the executives at these companies will be looking at, right? They want to be able to see what the numbers are telling them. They want to be able to provide, to get insights on business strategy and decision making. This is why your analysis is important. And then how you deliver this analysis is important, right? For me, personally speaking, long gone are those days where you just presented a report like on a grid, right, with a high number, like an Excel grid, basically, or some kind of web report. Now we got better tooling. We need to present the data better and visualize it, so the business is able to make decisions. Okay. So my friend at the top right there is telling me that I need to stop presenting and I need to start showing some actual code for us to enjoy. So let's do that. Let's move on. All right. So what's important here is that I put a link there for your for you to share the data project. The GitHub project that is available to us, right? So once you go to that GitHub project, all the code is here. Everything that we cover is found here with more background, right? More information. Today we are looking at step 5, which is the analysis and visualization. So we'll drill into that. But before that, I want to give you some background on what we're trying to do. The whole idea here, the whole purpose of this is that we have a problem statement that says that we want to businesses want to target customers based on a geolocation. So we need to gather that data, and based on the location of this subway station. So this is the data from a subway system in New York City. Based on that subway location, we want to be able to see the numbers. What days, at what time of that day is the most, how much people, how many commuters are in that location, right? For that business to target those user. So this is the background. Take a look at that. And the end result of this analysis will be to create a dashboard like this, right? This is what we're talking about today, right? Be able to create something like this that gives the total of how many commuters in what stations, in what, for what day, for what time, right? So this is the end goal. So you can take a look at that. But to start with, then we go to the data, step 5 data analysis. Here you have a lot of background on the things to read and the analysis, the requirements on what we're trying to do, right? And you can take time to read this. This is like the entire background of what we're gonna do, but we're gonna focus on the code right now. So quickly, what we do is this code, what you see here on Visual Studio Code is really the same thing, right? I'm just opening it through Visual Studio Code. And on step 5 analysis, you wanna open the analysis Jupyter Notebook file, right? So, which is, if you're not familiar with Jupyter Notebook, it's really just an easy way to generate, to run snippets of code using a target language. In this case, we're targeting Python 3.8, and there are other languages that you can target. And basically, if you're not familiar with Python, basically what we do is, and this is applicable to all languages, right? We import all the dependencies, right? The things we're gonna be using. And what you do is you run this through, just do Control Enter, or you do the play button here, and it will execute and it will load those dependencies. And now those dependencies are loaded in memory. And now you can move forward to do your coding, right? So what we're doing here is now we're saying, hey, for the data analysis, let's go ahead and get some of this data. So we have two options, right? Now you probably from your place, from your home, what have you, and you may not have a data warehouse available. If you did have a data warehouse available, following the process to establish that, you could run this code. This code really hits a data warehouse and it gets the data from there. If you don't have that, don't worry about it, right? You could just use a CSV file, right? So here we're going to use a CSV file just because it's there, it's in the repo, and you can use it at home. And it's just really a snapshot of the code that you will find from the data warehouse, right? So we just get this and we just run it, right? And what it does is part of the data analysis right now. So put your hat on, we're doing data analysis, and now we're saying, hey, I want to read the data, what's in the data, right? I see station name, created day, entries, exits, and this is a very simple data set, right? So in Python, you can say the info, data frame info, and that gives you information about the data set, which is important. So you start basically saying, okay, this is what I'm dealing with. Okay, and then I can describe it. And the description is really the data types. If you see that everything reads object, then there's a problem with the data set, right? And the problem is that object is basically string. And when you're dealing with, for example, created dates, right? That's a date time. So we kind of know that's a date time. 23/7/28 is a date. So we know, hey, we know we have to fix that, right? So we can describe the data and run some statistic if it's important for you, right? So this is important for statistical analysis. In some cases, if it's just BI, it may not be. So, but this is, we know we have to clean this up. So we need to do some data profiling, right? So what we need to do is we need to sample the data. We're going to sample the data and we're going to say, give me out of this result set that we know is, how much was it? Was 10,000, I believe. Yeah, it said 10,000 entries, right? So 100,000 entries. I'm sorry, 100,000 entries. So let's get some sample. Let's go at random and get sample data just to see the data, right? We don't want the top 10, the top 100. We want some random data just to make sure the data looks correct. And it does, right? We have the station, the entries, the exits, and so on. So we can display the top 10 and it's looking good. Okay, so let's go ahead and address the problems that we see, which is, we know the created date is not a string. Let's correct that. So what we can do is we can write snippet to do that conversion, right? So we can write a function here to kind of detect if the data type can be converted into date time. If we can convert that into date time, without any errors, we know that data type is probably a date time. And this is how we can send data across and for an entire series. Remember, we're looking at 100,000 rows, right? 100,000 rows. So we can create something called describe data frame, right? And that code, really what it will do here is it will just go ahead and pick up that data frame, pick up every column in that data frame, and do some analysis. It will say, hey, if you're a string, okay, then you're probably a dimension because you're categorical, right? But if you're string, you may also be a date. So, and if you are a date, then we're gonna check if you are a date, and if you are, then we know we are going to identify that as a date dimension. So this code just basically does that, right? And then what we do is we really get the sample data, right? Just to see what's out there, and we can run this, and it will do the analysis for us, and it will say, hey, this is what we found, right? We found station name is probably a dimension, and and created days a dimension, and so on. So you can actually start doing analysis, but this is just a rough way of doing it, right? We can do it through code, or we can actually start looking at some kind of profiling tool, right? And we can run something like this profiling tool, right? And we can kind of do some analysis. And what this will do, will actually look at that data set and it will analyze it, and it will create a report for us. And this report then we'll be able to to use it, to read it, to understand what's in there, right? So imagine if you have a lot of data, right? So a lot of data frames to deal with, because a bigger system has a lot more data to deal with, and then you can go ahead and run this, and this will just do all the entire analysis, and it will give you a report similar to this one that's here. And I'll try to open it with live server here. Right, and it's open in live server. Let's open it here. Okay, and it's loading. So it has this. I'm gonna blow this up a little bit, right? It has this report now that you can actually see some of the analysis that it's doing, right? It's kind of saying, okay, I found this variable, I found this information for it, right? I see its text and so on. Start saying, okay, I see this is a date, and it starts doing some analysis on that date. Excuse me. Entries, right? It says that there's high correlation, right? So it's doing some statistical analysis to see what the correlation may be, and so on. So this kind of tool gives you more details about what are you looking for, right? So this is really a way to profile your data, right? So of course, we got to clean up our data. We got to find nulls, and if they are, we have to make decisions. Do we drop the records? Do we fill them with zeros? We cast our dates to date time. We cast them to integers, right? You always got to make sure that this happens, right? You can't assume that the that the data is valid, even though it's a trusted resource. You always have to check this. You always have to maybe rename your columns. Maybe the DBAs did not follow your standards, so you need to do that. So all this is basically part of the analysis process, right? You find the outliers here. You can actually find the C-score from that data frame and do your calculation, and you will see some of the outliers here, right? So it's saying that First Avenue had outliers for entries and exits, and World Trade Center also had outliers. So what does that mean? Maybe there was an event, maybe that's bad data. The point is that you identify those, and then additional analysis has to be done on top of that. You look at distributions, right? Now you start looking at the data, you see that it has date times. So what are these time slots, right? You start doing distribution based on time slot, maybe morning, afternoon, night. You need to understand what the requirements are for you to be able to do this analysis, right? And then through Python, right, you have that file there. You can look and you can do this breakdown and kind of do the calculations yourself. And you start learning and understanding, right? Because you need to answer the question, right? You need to create some level of reports. You need to kind of learn from it to understand and be able to create that report. So also, you can look for outliers in for arrivals in the morning, in the night, And you can make that comparison, right? You can continue to run this code and do that and take a look and see and plot them too if you need to, right? And plot, and you see, so you see that based on the average, right? So let's say it's line 0. There's some outliers for 183 Street and Jackson Avenue and so on, right? You can kind of visualize and see. And this is mostly for you, for your analysis, for the development team, right? For the data team. And of course, this is background statistical analysis. We won't get too deep into that, so we can cover, so we have enough time, but you have it there and you can read about it. It is just really to try to create some correlation, right? And some diagrams about the correlation of the data, entries and exits, and are they correlated? Do they impact each other and so on, right? It's just really the study to do that, right? Hypothesis testing, which is really saying, hey, we're looking for some correlation. And you can kind of, if you run this, it's really what it's doing is saying, I want to look for correlation in the top 10 stations. And you will see the result is a number like P60.69, which is not significant. But if you take the entire cluster of data, all the stations, you will see that the p-value is 0. And what that means is really that you can't really say that 10 stations are really correlated, the 10 top station. They may have the most traffic, but everybody goes to different stations, right? So once you get the entire data set, then you understand that there's this distribution. Everybody's going through to all the stations. And as you add the whole set, then you understand that there is a correlation. And business intelligence, right? So you analyze distribution, and the distributions could be by your station, and then the total by total departures, total arrivals, and you can run the entire statistics. The whole point is that this is an exercise you got to do to understand the data. And once you understand that data, then the next step is, how do I present it? How do I present it to the business? What do I need to create, right? So let's answer that question. Okay, so we looked at the analysis, right? It's a lot of stuff to do depending on what you're trying to do. So you just focus on what you do, and then the answer is, how do I present it? Do I just display it on a grid, or do I create something more sophisticated? So let's see. Let's learn a little bit about what's data visualization. So you have data insights through data analysis, right? So now you need to present them in a visual format. You could pick a table, but a table really just provides raw information, right? And you kind of need to read it, and it's kind of boring, right? Executives are really picky when it comes to things like that. They're like, well, what is this, right? But visualization allows us to really display complex relationships and trends at a glance, right? So you just kind of see that, and you can see numbers, they stand out, right? You will see the numbers, and you will kind of get an idea of what you're looking at. So, visualization involves code-centric approach, where you actually write a lot of code, and you can use Python, JavaScript, and some of the Plotly libraries, and they're very good. They're very awesome libraries, right? Or you can use a low-code tool like Looker, Looker Studio, Power BI, Tableau, that are very powerful, friendly tools. Basically they do WYSIWYG type approach, where you actually design, you connect to a data source, you grab the data, you do your data modeling in there, and your formulas and your calculator fields, and you can do magic like that, and the quality is much higher, right? But it really depends on your budget, depends on the team, and so on. But the point is, when it comes to visualization, there are some design principles that we need to address. It's not just about creating a pie chart or donut chart or whatever, right? We need to be able to understand that when we're building this, we need to have a user-centered design in mind. What are they looking for, right? So executive CEOs are looking for total numbers that impact the business, right? So they don't need to see a lot. They just need to see a very high top level look of what the performance of the company is, right? Other people, maybe a manager, maybe district manager, now needs to drill down into that district and needs to look at the data and the departments within that district. So it's a little more blown up view of what he needs to look at. So we need to have that. We need to identify the role and have that in mind in design with that in mind. It needs to be clear. Long gone are those days where we used to pack as much data as possible on a one single view. That's cluttered, that's confusing. You can't really use it, right? So it needs to be very clear, very small, very compact. It needs to be simple. It needs to be consistent, right? And consistent means really use the same level of, for example, colors. If, for example, in your data set you have a category, right, and you, for that category, you use blue in one chart and you use red in another chart. Well, why? A lot of people will say, why is that red and why is this blue? Are you trying to mean something? And a lot of people, the red color actually means, like, for example, capital loss, or you're in the negative, right? So maybe red is not a good thing. But blue is a good thing maybe to represent station, a category, right? So everything that has to do with that station maybe should be blue. And if it is something else, maybe it should be green, and so on. So colors are really important, right? Filtering options, once you need to filter the data by day or by something, you need to be able to understand that. And it has to be responsive, right? Meaning mobile devices, desktop, and so on. Visual perception, important, right? Our brains are really geared towards visualizing things, right? So if we create beautiful visualizations with colors, with the right font size, with the right positions, right, the layout, in the different shapes, then we can definitely create something that's very good, very attractive, very appealing to the business. And here we have some examples of charts, like, for example, statistical analysis charts that we can use. This is just kind of standard charts, right? Very plain charts, business intelligence charts, scorecards, pie charts, and so on, right? Stuff we know and all that, but they're just charts, but they are really important building blocks for dashboards, right? Charts and elements. And when we talk about data visualization, we can do the coding approach, the code-centric approach, or we can use a low-code tool like Looker. And we're going to take a look at that so you can compare. So my friend here popped up saying, let's look at that. Let's look at the code. And really quick, let's jump on that. So when it comes to this visualization, you want to take a quick look at the dashboard. I hope you can see it. There's a dashboard Jupyter notebook, and that just gives us some playing exercises on how to do dashboards, right? It will just go ahead and do load data and just create dashboard visualizations that are very, very, very simple visualizations. But the whole idea is that you can code it that way, prototype it that way, then create something that is written here in this dash py, which is really an export of that file, to grab that data and do the different components, right? So we can, like, do a day picker range, right? Do a car. If you notice, there's a car there, and so on. So this gives us the whole set of how do you visualize this through code. And you can just take more time to look at it and understand how this works. But just to show you how it runs, right? We just run through the command line. If you see me typing, I hope you can. Right. So what it will do is we will run this Python file and it will run an application, right? And this application really is a Dash application, which is really just a web application that runs Python code. I personally will use JavaScript in some other cases, not because I have a preference to it, but you can use Python as well. But this is just a simple way to demo this, and you can take time and look at the code and how this layout is built, so you can see what this looks like. So when we open this, right? So let's see, did it open? Where is my application? So it's on port 8050, it says. Okay, let's open it. Right, so let's open this. Okay, so what you will see is some of the stuff that we kind of started talking about, right? Where we have a data picker, right? And then we can filter by the day, and this is all, by the way, HTML, right? and we can select our distributions. We have our cards for total entries, total exits. So these are scorecards that are very important for this. Top stations by entries and so on, right? Exit by days, right? So, and you can see that we did some code to be able to break down and identify the dates and then the hours, right? So we did that stuff. And all of this is basically, you can drill down into it and you can select it. But all this is code written through code, right? So we did all this code here. We created, right? We built a bar chart here, create a bar chart, and create the time bar chart and so on. So there's a lot of code to do this. So what that means is there's a lot of deployments, there's a lot of things like that. How can we make this, how can we use this or create something similar using a low-code tool? So let's take a look at that. So, and also the quality, look at this, right? If you present this, this is kind of cool and all that, but it could be better, right? It takes a lot of effort to design it, put cascading style sheets, it make it look very good, right? Some of you may say this looks decent enough, but a lot of people will say, no, this is very plain. But if we start looking at a tool like this, right, look at the difference, right? So the design now is incredible. We have our drop downs here where we can filter, right? So remember the date dimension, the calendar dimension, to allow us to filter by dates. We need another one dimension for categories, which is the station. So remember, the end goal is to target a geolocation, and the station name could be used for that particular business, right? So and then we have the same scorecards, the donut charts, the dates. Let me blow this up a little bit in case, right? The dates, distribution by hours. But how do we do distributions by day, by hours? How do we do this, right? What is the approach? So the good thing about these tools, enterprise tools, that they have great editing capabilities and design capabilities. The way this works is that you add a data source, right? So you can add a data source, and what that is really just the ability to connect to use a connector, right? So you can use any connector here, SQL Server, BigQuery, and whatever, Maria database, whatever it is, and you connect through that, you give them all the security information, and it will just connect to that data model you created, and then you'll be able to pick the different fields, right? The name, the station name, like the time, the exits, and so on. And then you'll be able to start drawing your chart by dropping components into it. And the components are a table component or a scorecard, a bar chart, and so on, right? So there's a lot of components that are pre-built for you to accelerate your development, right? Or you can build something your own. So there's a lot of functionality in the back to customize it, but the idea here, you don't want to spend a lot of time coding it. And the way this works also is when you grab a bar chart, right, you will connect to that data source. You will connect to the dimension date, right? Because it's the overall filter, remember. So we filter by that day, and then to a dimension, which is the station name. And then you'll be able to do the distributions. What kind of distribution you want? And you want the distributions by entries, right? So, and then you will get the aggregated data. One thing to notice here is that some of this stuff is really out of the box, but when it comes to something like daytime, right? Like, for example, 12 to 3:59 and things like that. I mean, how do you do that, right? And by the way, look at how all this is connected. If I pick a particular time frame, it filters everything, right? If I pick a particular station, it filters everything. So bear that in mind, that we're really now doing a zoom in filtering on this. So, but the way to customize your data points here is that we need to create our own measures. We need to define our create calculated fields. And the way we do that is by creating some functions here that we can, for example, if you see this function here and you click on it, we actually do what we do on the Python code, right? We're saying, hey, use the create date, but do this mapping for me. And this is something we write, right? This could be different for your case, something completely different, but this is how you will do with this little snippet. You will do that measure to enable you to display data differently, right? So let's go back to, I know we're running out of time, but basically, final thoughts on this. Your decision, right? To always remember data analysis, visualization, understand the components for visualizing your data. And definitely, the future is bright for data analysis, right? And visualization. There's augmented reality, VR devices now that you can explore data sets using 3D, right? AI and machine learning are helping us do now. AI can help us do data analysis. A lot of stuff we do through code, AI can actually create some of the scripts. If you give them a data set definition, it will generate a lot of the stuff for you. So the thing is, the future for this is really good. There's a lot of potential here to continue to grow visual and for the visualization tools, and which is an important area to cover. So we went quickly around this. There's a lot more information. I just gave you the highlights for it. You can get more information. The book is there. Contact me on Twitter, LinkedIn if you want. Follow the GitHub repo, please. Give us a star. It helps us to continue to grow the project, to continue to do more things for the community, for us. Okay, so thank you so much. I haven't had a chance to see if there are any questions since I'm tied up here a little bit, but let me see. Does Looker Studio have an API? We're going to implement this in the code. Does it work well with Flutter? What I believe Looker, just like Power BI and Tableau, what they have is what's called embedded charts. So you can actually put that on any HTML, right? Or any device like Flutter. If you look at targeting mobile devices, or you're targeting web pages. But the approach for this is not to call an API, because if you call an API, you're kind of grabbing data. For example, is to actually grab the embedded text of the component for that chart and pass parameters to that chart. So, and let the component for Looker or Power BI to get that as filter criteria and display what that design is supposed to display. Okay, that's how you will do that. So, but anyways, everyone, thank you for such for joining me today. Follow me, please, on the GitHub. Give the GitHub repo a start, please. That helps a lot. Also, if you have any questions, just go ahead and follow the YouTube channel. Also, and that definitely is a great help for us. Thank you, everyone, and have a wonderful day. And keep up to date with latest other presentations. We have presentations. Please, there's web presentations, data engineering presentations. So stay with us, okay? Thank you so much, everyone. Thank you. And thank you for your feedback.